Welcome to Signals and System subject classes. Now we are in the fourth chapter, that is discrete time Fourier series. So this is the fourth video. So last video. So in this class we are going to revise the whole chapter. So it is very useful whenever you are preparing for your examination in last week of the exam. So discrete time Fourier series, directly I am writing the Fourier series, discrete time Fourier series representation. So that is discrete time Fourier series representation. So any we know that it is applicable for the periodic signal. So discrete time it is applicable for periodic signal. So whether it is continuous time or discrete, so Fourier is always applicable for only periodic signal. That's we should remember. So any periodic signal in this case we are taking the discrete time signal. So it can be represented in terms of the complex exponential. So sigma, so sum of the complex exponential ak into e power jk omega naught into n. K, so here in this case ak is the periodic. So k limits for the one time period. So Fourier series coefficient formula ak equal to 1 by n sigma x of n into e power minus jk omega naught into n. Here n, it is also x of n periodic signal. We know that ak is applicable for the periodic, x of n is a periodic. So n must be within the one time period. So here I am writing the Fourier series coefficient for the periodic signal, that is already we derived one rectangular pulse train I am taking here. So that equal to x of n, this is the one for the case mod n less than n1. So within the minus n1 to n1, minus n1 to the plus n1, it is having magnitude 1, and half of the time period to the, so n1 to the half of the time period equal to 0, is it? For this case, the ak Fourier coefficient formula, that equal to ak equal to sin k omega naught into n1 plus 1 by 2 by n into sin k omega naught by 2. So this is one time periodic signal. The next one, impulse train. So that impulse train x of n, that equal to sigma, so del of n minus m into capital N is the time period. So m it from the minus infinity to plus infinity. So it is discussed in the previous class, end of the previous class. So ak equal to, so ak how much we got it? That equal to 1 by time period. So your time period equal to n. So this is about theory. So properties. So before going to properties, here directly I'm writing, I'm taking two signals. So two signals, Fourier series coefficient. One ak Fourier series coefficient equal to ak. So y of n is Fourier series coefficient equal to bk. Fourier series. So the first property, linearity. So linearity is nothing but some taking the multiplication to the one signal and plus additivity property. For the linearity, it should follow the additivity and scaling property. So B into y of n. So A into AK plus B into BK. Next, time shifting property. Time shifting. So time shifting x of n minus n naught. So delayed signal for this. So AK is multiplied by the exponential e power jk omega naught into n naught. Frequency shifting. Frequency shifting. So AK minus m. Shifting in the frequency domain. Then in time domain, x of n is multiplied by the exponential, that is e power plus j. Plus j, in place of the k, you should take this m. M is the constant. M into omega naught into n. So this is the function of the n. This is the function of the k. Fourth one, complex conjugation. Complex conjugation. So this is conjugation, is it? You can write complex conjugation. So complex conjugation. Complex conjugation for the x of n is it is one signal. So it's complex. So complex. Then that equal to a minus k and complex. Fifth one is time reversal. The time reversal, so x of minus n, so that equal to a minus k. The sixth one, time scaling property. So the time scaling, so this is a discrete time. You know that for the time must be integer for that. So for example, x of n, m. So x of n by m, but this n by m, it must be integer. Then only it becomes the discrete. We can say it is a discrete. Is it? So the condition must be n is multiple of n is multiples of m. If it is not multiples of m, it is not discrete. So that's why we should take that value equal to 0. So n is not multiples of m. So for this case, the Fourier coefficient, simply the 1 by m is multiplied to the ak. So next property, so that is seventh one. Periodic convolution. So you know that convolution in the time domain, in frequency domain, that must be multiplication. Vice versa. For this case, and directly applying the convolution. So x of n convolution y of n, it becomes, so sigma. So x of m, then y of n minus r, n minus m. So this is a periodic. So we should take within the one time period. So for this case, n into ak into bk. Already I told you the convolution in time, the corresponding frequency domain, it must be multiplication. So vice versa. So multiplication in time, so frequency domain, it must be convolution. So multiplication so x of n, y of n, so that equal to, so now multiplication in the frequency domain, that equal to al bk minus l. So here what we should take the limits for the l. So ak also periodic, then should take the l within the one time period. That's enough. So this is multiplication and this is convolution. Ninth one, differencing or the first time difference. Can take any differencing. Both are same. So for this case, so x of n minus x of n minus 1. So that goes to 1 minus e power minus jk omega naught into ak. Next, summation sigma x of m from the minus infinity to n for this case. So this factor is multiplied in this case, but here, so this factor is divided. So ak divided by this factor. That what is the factor? 1 minus e power minus jk omega naught. So in the case of the differencing, you should multiply this factor. In case of the summation, just divide by this factor. That is the difference. So 11th one, conjugate symmetry. For the conjugate symmetry, I'm taking the x of n is real. Then I'm going to compare. So ak, already we learned the for the complex of the xn, that is what? A minus k complex conjugate, is it? So for the case of the real, it becomes the ak. So real part of ak, that equal to real part of a minus k. Similarly, imaginary part, but imaginary part will get some minus difference. So imaginary part of a minus k minus, so the mod, it will be equal. So a minus k, mod of a minus k. The angle 180 degrees phase shift. So ak angle equal to minus angle of a minus k. So this is the conjugate symmetry. Should remember all this. You will get a question from this topic. The 12th one, real and even. So x of n is real and even. There is no change in the Fourier series quotient. So ak also real and even until unless it odd. Is it? So next, real and odd. Now signal it is in the odd. So ak, it becomes changed from the real to the odd. So ak purely imaginary. purely imaginary and it is odd. Fourth one, even and odd decomposition of real signal. So even part of x of n, so that equal to real part of the a key. Similarly, odd part of equal to j into imaginary. The last one, partial relation. Last one, Parseval's relation. You know that the relation, so this relation, it tells about relation between the time domain, frequency domain, power of the time and power of the frequency domain signal. So x of n, this is power sigma 1 by n within the time period. Already I told you how to remember this formula. Just write the x of n formula. So x of n formula is nothing but Fourier series representation. That is equal to sigma a mod of ak square. The mod of the exponential goes to 1. So k within the time period. Why? Because ak is a period signal. Now write the formula for the ak. Ak formula equal to 1 by n sigma n within the time period mod of the x of n square. Yeah, so the square of the signal is nothing but power. So the mod of the exponential goes to 1. So this is the partial relation. It's very, very important. So this is about fourth chapter related to the discrete time Fourier series. Then next class we will go for the Fourier transform of the continuous time. Thank you.